Hey everybody, we are going to talk about some 3D geometry today. For the Indiana 7th grade standards, it doesn't go too terribly deep into it. Right now we're just going to be focusing primarily on prisms and cylinders. So the first thing I want to talk about is a prism. A prism is like a box. Think of it like a shoebox. In a prism, you're going to have two matching bases. The bases aren't necessarily going to be what it's standing on because, it could be laying on its side. But the bases are the two that are identical. They're parallel to each other like train tracks, and they are identical to each other. Then those two bases are connected by rectangles. When you name a prism, you name it for the bases. So some common examples that you'll see, a rectangular prism, we have these two rectangular bases that are equal to each other, and then those are connected by four other rectangles. This one is, technically it's still a rectangular prism, but more specifically, we're going to call it a square prism because the bases happen to have four equal sides. So here's our two square bases. And then again, those are connected by four rectangles. If every single face is a square, so you can't tell what the bases are because every side, every edge, everything is identical, then it's called a cube. A cube is a rectangular or square prism, but more specifically, even the rectangles that connect those bases are also equal to the bases. So in a cube, everything is an equal square. A triangular prism, we have our two triangle bases. And then since those have three sides, those are connected by three rectangles. If you have pentagons for bases, those would be connected by five rectangles because a pentagon has five sides. A net is if you think about cutting your three-dimensional shape, cutting it and then laying it out flat. It's kind of like a blueprint. It's what you're going to fold up along the edges to complete your 3D shape, your 3D solid. So on this first one here, the two sides that look different from the others but like each other are these two triangles. And then with my triangles, I have three rectangles. So that means that's going to fold up into a triangular prism, a triangular box. Okay, on the next one, it looks like these are the bases because they're like each other, but not like the others. Those appear to be rectangles. And then we've got four additional rectangles that would connect those. That's a rectangular prism. Now, this next one, I would say to be safe, if you don't know the measurements, if you're not positive that everything is identical, just call it a square prism. But if you do know that even these are equal to the bases, then more specifically, you could call it a cube. I mentioned a little while ago if your bases are pentagons. So here's one where we have five-sided figures. We have pentagons, and then they're connected by five rectangles. You can pronounce that pentagonal or pentagonal prism. If your bases are hexagons, you can call that hexagonal or hexagonal prism. Same way for pyramids. So speaking of which, right here, this is totally different than what we've been talking about, but I've got this one hexagon in the middle, and then I've got triangles. If I fold those triangles up, they would meet at a point. So what this is actually going to make is a hexagonal or hexagonal. Anybody know what it's called? It would be a pyramid. I know you guys have seen pyramids. And those are named just like the prisms. It's named for whatever shape the base is. So this next one is kind of like a prism, like a box, except my bases are circles. And then connecting those circles is a rectangle that wraps around the circumference of the circle. It makes a can, right? It makes a cylinder. So what about this one? I have one circular base, and then I've got this kind of triangle with a rounded bottom that if I fold the circle up, it would wrap around it. And then I would just have a point up at the top. You know what that one's called? That would be a cone. Like a party hat, ice cream cone. When you want to find the volume of prisms, this is going to be true for cylinders as well. You're going to find the area of a base and then multiply it by the height. The height is the distance between your bases. Now, if everything's a rectangle, what you would have learned when you were younger in elementary school is you just multiply the three numbers. Because look, on this one, if this is my base, that's a 2 by 5, right? 2 times 5 is 10. Multiply by the distance between the bases, the height. So 10 times 10, I get 100. I get the same thing if I just right away multiply those three dimensions. When you're dealing with volume, because you're dealing in three dimensions, it's how much it takes to fill the object. Think of like filling a pool or putting sand in a shoebox. Three dimensions, so your units are cubed to the third power. That one would be 100 centimeters cubed. Here's another one where your base is a rectangle. So the base right here would be 7 times 4. And then you take that times the distance between the bases, so times 15. Remember, multiplication we've talked about is commutative. That means you can go out of order. So instead of trying to figure out 28 times 15, I know 4 times 15 is 60. 60 times 7 would be 420 because 6 times 7 is 42. And then that would be inches cubed. Now this next one's going to take a little extra brain power because the base is not a rectangle. I've got to find the base of this, or the area of the base, which is a triangle. A triangle, you take 1/2 times the base times the height. And it doesn't matter what order you do that in. I'm going to take half of 8 is 4. 4 times 6 is 24. Then you take that area times the height, the distance between the bases, which would be 7. So if I do 24 times 7, I get 168. And that would be centimeters cubed. Here's another one like that. The base is a triangle. The area of a triangle is 1/2 times the base times the height. Let's see, half of 20, that would be 10. Take that times the distance between the bases. That's called your height. It's how tall it is if you stand it up on the base. 10 times 6 is 60, so that would be 60 centimeters cubed. Surface area, where we talked about volume is how much it takes to fill the object. Surface area is how much it takes to perfectly cover the object. If I was going to cut out wrapping paper and not have any of it overlap, but measure it out perfectly so that every little bit of each face, each side was covered, that would be the surface area. So really what you're doing is you're finding the area of each side, each face, and then adding those together. So let's look. The front and back on this one would be a 5 by 10. And I have 2 of those, right? 2 5 by 10s for the front and the back. How about the top and the bottom? Let's see. This is 10 across, and this is 2. So the top and bottom, that's 2 of those, are 10 by 2s. And then the left and the right, it's 2 and 5. I have 2 of those for the left and the right. So 2 times 5 times 2. And then once I figure out what those are, I'm going to add them all together. So 5 times 10 is 50. 2 of those is 100. 10 times 2 is 20. 2 of those is 40. 5 times 2 is 10. 2 of those is 20. I'm going to add all those areas together, and I get a total of 160. Even though this is a three-dimensional shape, we're looking at two-dimensional areas. So this, for any kind of area, is still going to be your units squared. 160 centimeters squared. Okay, so let's check out the next one. Let's start with the front and the back. So the front is a 7 by 4. Front and back match, so that's 2 7 by 4s. Should have left myself more room. Also should have waited for the bell to ring before I resumed recording, sorry. How about the top and bottom? That would be a 7 by 15, so 2 of those. And then the left and the right, let's see, it's 15 this way and 4 this way. So 2, 15 by 4. Okay, let's figure out what that is. I'm going to write them down below. 7 times 4 would be 28. 2 of those is 56. I'm going to go out of order on the next one. Instead of doing 2 times whatever 7 times 15 is, I know 2 times 15 is 30. 30 times 7 would be 210. 15 times 4 is 60. 2 of those would be 120. Add those together, and I get 386. We're dealing with area, so that would be inches squared. I'm going to circle these since this is going to start getting crowded. Okay, next one. We're going to have 5 areas on this one because there's 5 faces altogether. My front and back are triangles. So that's going to be 1/2 times 6 times 8. That's the area of the triangle here. But I have 2 of those. This rectangle over here, this is 7. And you know what? The paper that I took this from was actually an 8th grade worksheet. And this would be done after we'd already studied the Pythagorean theorem. So take my word for this, because this is not my Pythagorean theorem video. You would find that this side of the triangle, the hypotenuse, the longest side, would be 10. So that means this rectangle is a 7 by 10. But I only have one of those, so I'm not going to say times 2 because it's just that rectangle there. The rectangle on the bottom would be 8 by 7. And then let's think about this one over here on the side. It's 6 this way. And then going back, it would match up with the 7. So 6 times 7. Okay. The 1/2 times 6 times 8, I can do that and then double it. Or if you take 2 times 1/2, you just get 1, right? If you find half of something and then you double it, it's like you never did anything. So what's going to end up happening is that's just going to equal 48. And then I've got a 70, a 56, and a 42. So the total surface area is going to be what I get when I add all those up. Let's see, that's going to be 16, carry the 1, 5, 12, 17, 21, 216 centimeters squared. Let's do one more of those. Okay, the front and back on this last one here are triangles. So again, the triangle is 1/2 times the base times the height. Whoops. I didn't actually put a plus. I was just kind of writing sideways. So that's what it looked like. The front and back are going to match. So I have 2 of those. The bottom is going to be a 4 by 6. This way. Okay. So again, my goodness, I wish I would have realized that I was pulling this from something that should have happened after the Pythagorean theorem. Let's see what that would be. So 4 plus 25. Oh, that's going to be a gross 1. Way to go. So Pythagorean theorem, if any of you are watching this and you have learned it, you have to take a squared plus b squared equals c squared. This whole thing is 4. This would be 2. So I would do 2 squared is 4. 5 squared is 25. Add those together, I get 29. This is going to be the square root of 29. Square root of 29 is going to be super pretty, isn't it? Because it's not going to be a rational number. We're just going to round it. We're going to call this 5.4. And it's okay that it's a decimal because in real life, not everything is a whole number. So we're going to call it 5.4. So that rectangle is going to be 6 times 5.4. And the one on the other side is going to match it. It's going to be identical to it because this is like a tent and your tent's standing straight up. So I've got 2 of those, 2 of the 6 by 5.4s. I'm going to switch to a different color so that you can see what I'm doing a little bit better because I know I'm about out of room. Okay. 2 times 1/2, again, that cancels. So really, that's just going to end up being 20. 4 times 6 is 24. Let's see what happens here. 2 times 6 is 12. If I do 12 times 5.4, I get 64.8. For the total area, the surface area, I'm going to add that up. So 64.8 plus, that would be 20 and 24 together is 44. Add all those up, you get 108.8, and they were centimeters, so centimeters squared. Okay. So we talked very briefly when we were looking at nets about a cylinder. A cylinder has sort of the same characteristics as a prism, but you can't actually call it a prism because the sides, the bases, aren't polygons. Polygons are when you have straight sides. They're circles. So what happens is you've got the two circle bases, and then you've got a rectangle. If you're watching this and you've got a piece of paper near you, pick up your piece of paper and just kind of let it roll around so that the two edges are touching. That's what becomes the can part of your cylinder. It wraps around the circumference of the base. To find the volume is still going to be area of the base times the height. So you're going to do the area of a circle, which we've talked before is pi r squared. Take that times the height, which is the distance between the bases. So for this first one here, I'm going to do pi times 3 squared. And then I'm going to take that times the height of the whole thing, which is 10. For pi, we're going to use 3.14. So this is going to be 3.14 times, you can just go ahead and put times 3, or we know that's a 9, and then times 10. I'm going to do 3.14 times 90, because remember, multiplication is commutative. You can go out of order. 3.14 times 90, I get 282.6, and those are inches cubed because volume is three-dimensional. We're filling the object. Okay, let's do this one. Area of the circle, pi, or 3.14, times, it's not the 14. You want the radius. This is the diameter all the way across. So the radius is half of that. The radius would be 7. So times 7 squared, or 49, times the height of the whole cylinder, which is 10. So I'm going to do 3.14 times 49 times 10. I get 1,538.6. Volume is 3 dimensions, so that's centimeters cubed. Okay, surface area of cylinders. Last one. This one looks really gross. But what I keep telling you is that with a cylinder, that can part is really just a rectangle. We know that to find the area of a rectangle, you do the length times the width. You multiply the two numbers, right? What we have to remember is that the length is actually the circumference of the circle because it's wrapping around the circle. So, okay, let me just start showing you. We'll kind of break this down. I'm going to do 2 times the area of the base. So 2 times 3.14 times r squared, 3 squared. So here's, actually, why am I doing volume when I was talking about, oh no, I'm right. Oh my goodness, I'm trying to multitask right now. I'm at school and I just went momentarily stupid. If you've watched any of my videos, I find myself again telling you that I swear I'm a smart person. I just do dumb things sometimes, as I keep giving you evidence of in my videos. It's never boring around Luger. Never boring. Okay, let's get back to it. Let's remember what we're doing here. So 2 times pi times r squared. This is the area of the base. We have 2 of those. So that takes care of the top and the bottom. Oh my gosh, you guys, I'm such a dork. I swear, I'm sorry. Then I also need to add the rectangle part that makes up the can that wraps around them. Rectangle is length times width. The length is the distance around your circle. That's called the circumference. And you find that by taking pi, 3.14, times the diameter. C equals pi d. Crust equals pi dough. The diameter, if halfway is 3, then the whole way is 6. That's the length of my rectangle. The width of my rectangle, or you can also call that the height, is the height of the whole can. So times 10. So essentially what I've done is this. I've got the circle on top with a radius of 3. So to find that area, it's pi times 3 squared. Okay, I've got the circle on the bottom, which is identical. That's why instead of writing it out twice, I just said times 2, because it's exactly the same thing. So that's up here. Here's pi times 3 squared. I have 2 of those. Then I've got the rectangle that wraps around it. The length of that rectangle is the distance around my circle. That's the circumference. You find that by taking pi times the diameter. The diameter would be 6. The height of the rectangle, or the width, is the height of your whole can, which is 10. So that area is 3.14 times 6 times 10. That's where this part came from. Okay, so now I'm going to start simplifying. I've got, let me pull up my calculator, 2 times 3.14 times 9. The circles have a total area of 56.52 plus the rectangle, sorry, another bell, it's for the 8th graders to go to lunch, 3.14 times 60 is 188.4. I'm going to add those together, and I get a total of 244.92. This is area. Area is always 2 dimensions. We're not filling it, we're covering it. So that would be inches squared. Let's do one more of those. I know these are definitely the trickiest out of all that I'm showing you in this lesson. All right, I'm going to switch to a different color for this. I'm going to try to not momentarily lose my mind on what I'm doing for you. So my circles, my top and bottom. I know that the whole way across is 14. So that means halfway across is 7, right? I have 2 of those. And to find the area, I take 3.14 times 7 squared. I'm going to try to write this one a different way and see if you maybe feel a little bit better about that one. This one is also 3.14 times 7 squared. Okay, then I've got the rectangle, right? The rectangle that wraps around the circle. So the length is the distance around the circle. I find that by taking crust equals pi dou, C equals pi d. So I'm going to take 3.14 times the diameter, which is 14. That gives me the length. And then times the height of the whole thing, which is 10. So 3.14, should have left more room, times 14 times 10. I'm going to find the area of each one of those, and then for the total surface area, I'm going to add them together. Okay, so grabbing my calculator again, I'm going to do 3.14 times 49. That gives me 153.86. This circle is also going to be 153.86. The rectangle, 3.14 for pi times the diameter, which was 14, times the height of the whole thing, which is 10, gives me 439.6. I'm going to add all of those parts together to get my total surface area. So 153.86 plus another 153.86 plus 439.6. I get a total of 747.32. And those are centimeters squared. Remember, area is always squared, volume is always cubed. Okay, so that's what you need to know for right now about three-dimensional geometry. Hopefully this helped you out. My students, you can look back on this for your homework assignment. Make sure you check Canvas for details on that. I just tried to put an R in Canvas. I'm doing great. I've got videos for every lesson that I teach. So if there's any other 7th grade standards that anybody needs help with, please check out my channel. It's Math with Luger. I've got a classroom Facebook page if you need to reach me or get updates on my classroom, and there's my school email. So as always, thank you so much for sticking it out with me. It's been a few weeks since I've recorded a video, and apparently my brain is not fully connecting to my hand or my mouth, and I keep doing and saying stupid things, but that's okay. Again, we're never bored, right? Thanks so much. Bye.